In this video, you will learn how to perform primary data collection. That is, how you collect the relevant mosquito samples for your study. Systematic collection of primary data is a key part of field-based research. You should always use standard data collection methods. In this way, other researchers will be able to validate your researches. It is important that you know how to collect, label, transport, register, and store your samples for data analysis. So please follow the instruction provided in this film and remember to check available literature for further details.
Well, as you may already know, that vector-borne diseases contribute about 17% of global burden of diseases, and mosquitoes form a larger part of this vector-borne disease burden. Some species in this could be vectors. We have Aedes mosquito that transmits several diseases, including dengue and chikungunya, etc. There is Anopheles mosquitoes, which mostly transmit malaria and other parasites and other pathogens. Also, Culex mosquitoes also can transmit filariasis. Research on mosquitoes could either focus on larvae or adults, or in some cases both. If your interest is on larvae, the interest of variables could be either how many larvae or number of larvae are there, where do they breed, or the type of habitats, and also what are the species of these mosquitoes. And on adult mosquitoes, if you're focusing on adults, your variable of interest could be either the feeding habits of the mosquitoes, the density of these adult mosquitoes, could be insecticide resistance status, and other variables depending on your research objective.
So this is what's known as a light trap, and we use a light trap to trap night-biting mosquitoes, including Anopheles and also Culex. The light trap is set in a room where people sleep, a room which is inhabited by people, and we use the light trap to attract mosquitoes, and we set it for about 12 hours during the evening time, and we collect it during the morning. Now, we use the string to attach the light trap to a nearby connection. It can be a nail or a string that is found in the room, and we set it about 1 meter from the ground. And it is set in a place where it is closer to the sleeping person, the better. And it derives its name from a little lamp that can be found here, which is connected to the battery that illuminates during the dark, attracting the mosquito. So once the mosquitoes are trapped during the entire duration in the night, the collector uses these strings to close the net, not allowing the mosquitoes to escape and trapping them inside. So yeah, so basically we connect the light trap to its battery, the red to the positive side of the battery, and the black one to the negative side of the battery. And you can hear some sound coming from the light trap, which originates from the fan that acts as a vacuum that sucks in the mosquito. In the duration, which is about 12 hours from evening to morning, the mosquitoes are trapped in this little cup in here, which will later on tie to restrict the mosquitoes from living. So after 12 hours of operation, we're now ready to retrieve the trapped mosquitoes for further procedures. So we've tied the net so no mosquitoes can escape. And now we can remove the net from the main part of the light trap, as shown. And so if you come closer, you can see some mosquitoes. Some are alive and some are dead. So once we've retrieved the mosquitoes, we label the cup based on the location and the household number and also the sampling ground. So in the current location, we use number 1, and then we use the household number, which is 7. And then we end up with the sampling ground, which is 6. So this specific code allows us to retrace the mosquito back to this particular house and this particular location. So we can use this code to also assign it to the Eppendorf once we're in the lab, which can also later on be used to trace the mosquito back to its roots. This is the BG trap. The BG trap consists of many components. We have the bag right here, which we use to store the carbon dioxide generator, and the tube, which then transfers the carbon dioxide to the trap door. We also have the rain shield that protects the trap from rain during rainy seasons. We also have the net right here, which we use to store the mosquito attractant or the BG lure. We also have a tiny small net inside the trap that keeps the mosquitoes trapped. Now, the BG trap is used to trap a specific kind of mosquitoes, mainly the day-biting mosquitoes like the Aedes species, but it wouldn't be surprising if we were to find another species of mosquitoes like the Culex, but in very small numbers, or even none at all. Now, the BG trap is set operational by connecting the trap to the battery, which is stored in the battery compartment. So this right here is the battery. It looks like an ordinary power bank. Now once we connect it, you will notice that the trap door automatically opens, and then there's a wiring sound coming from the motor that is inside the trap. So we store the battery inside the battery compartment. And we have the BG lure right here, which is a mosquito attractant used to trap this specific kind of species, or this specific mosquito species. So we place the BG lure inside the net. The BG lure has unique characteristics that allows it to imitate the scent of a human body. So once we place it inside and the trap itself is running, the trap is now fully operational, and any Aedes mosquitoes in the vicinity will be attracted by two things: the mosquito attractant and the carbon dioxide that is running through the trap door. So once we've unhooked the trap from its original position, we remove the rain shield and the handle. Okay, and then we detach the terminals from the battery or the power bank, making sure that the trap door closes itself. Oops. Okay. So once the trap door closes itself, we release or unhook the head of the trap, which is connected to the net inside, and then we ease the grip a bit, not too much, to make sure that the mosquitoes do not escape. And then we pull it down slowly, and then we hold it tight on the top of the net, and then we remove it, and then we pull the grip, the neck of, there it is, the mosquitoes are now secured. And so we place the collected mosquitoes in the cool box. Now we can disassemble the trap. This is the backpack aspirator, also known as the Procopack aspirator. The Procopack aspirator is used to collect mosquitoes in both indoors and outdoors environment. The Procopack aspirator can be used to collect adult Aedes mosquitoes in outdoors areas, but also adult Anopheles and Culex mosquitoes in indoors areas. The Procopack aspirator has a powerful motor that pulls the mosquito inside. We have the cup right here, which we then insert into the aspirator, and then we open it. So once the trap is operational, we turn it on by turning the knob right here. You can hear the strong wiring sound indicating the presence of a strong motor that pulls in the mosquitoes and keeps them trapped in the cup, which we then close and then turn off the trap. Now, the Procopack aspirator is connected to a powerful 6-volt battery that I carry in my backpack. Once we've searched and aspirated through all the potential hiding places for mosquitoes, we now remove the cap from the Procopack aspirator, and then we check for the presence of any mosquitoes. You will notice there are some live flying mosquitoes. So we now label the cap based on the location or the sampling site and also the household number. So the location is number 1, has been assigned number 1, and the household number 7, and then the collection round, which is 6. So this code can be used to trace the mosquito back to the household and the site of collection. For larvae collection, we start by systematically searching through the surrounding. Now, for Anopheles species, we search for open bodies, for example, lake or rivers. But for container breeding mosquitoes like Aedes and Culex, we search for man-made containers or any other sources that can store water in the surrounding. A lot of containers that can be unlikely can act as a breeding site for mosquitoes. For example, this tire can collect water during rainy season. You will see that there is a certain amount of water that collects, which acts as a perfect breeding site for Aedes species since the water is clean and clear, and it's also near to the household. So we can search and see if there are any larvae or pupa that has been formed. So this is a negative container. So we search the surrounding. So right here we have an extensible dipper that we use to reach for water, pipettes, and a vial for storing the larvae that we collect from our breeding source. So we pour a water sample into a white container. There is a pupa right here. We do have some worms, but they're not what we need. Okay, we do have another larvae. So we can take another dip for the collection, and we can discard the unwanted species. Okay. So once we've stored the larvae in the vial, it's imperative that we make sure there are no predatory species that might attack or eat our mosquito larvae. So we have our vial that is only filled with mosquito larvae and pupa, and nothing else that might lead to harm to the collected samples. So once we've gotten the sample that we want, enough number of mosquito larvae or pupa, we close the cap, but not too tightly, to make sure that there is entrance of air so that the samples or the mosquito larvae do not suffocate. And then we can label the vial based on the location of the breeding site and the type of container. So before collecting the adult mosquitoes and the larval mosquitoes, we store all the necessary data in a specific tailored software called the ODK that is also integrated with the GPS tracking system that allows us to extract the exact coordinates of the breeding site or the adult mosquito collection site. So we can enter the information of the type of storage used, the type of water used, if it's rain or collected water, but also if there are any comments that are needed according to if the trap functioned correctly, or if there are any sorts of impairments in the functioning of the trap.
Okay, so now the samples are ready to be transported to the insectarium at Mbweni campus, and for species identification. And this species identification will be done in 2 different ways, using molecular identification keys under the microscope on one hand. On the other hand, they'll also be identified using molecular techniques.
So once we've transported the mosquito samples from the field, we temporarily store them in the cool box. We try to cool down the mosquitoes so that they can hibernate or fall asleep. And then we retrieve the samples from the cool box. We have different samples from different traps. Once we retrieve samples, we then identify the type of mosquitoes based on the species that we have collected from the different traps in the field. So we do the identification process under a microscope, which we can see right here. So once we've retrieved the samples from the cooling box, we now proceed to identification, where we remove the mosquitoes from the trap. And then we open it. Now, we can choose to identify with our naked eyes if we can detect the presence of multiple species of mosquitoes. We can also use the aid of a microscope. We use the mosquitoes to identify any features that will pinpoint the exact species of this mosquito. I have a female, a female, a female, a female. So we've separated the Culex species into male and female mosquitoes, and so we can store them accordingly based on the species type and their gender. So once we've separated the species into the male and female, we store the female species into the Pendorf tube. So we use the tweezers and the forceps. Okay. Now, it depends on the type of the research question. If the male counterpart are needed, then they will be stored for further analysis, but if they're not, they can be discarded. Now we use a masking tape. Okay, and then we label the piece. Now we know that it is from light trap number 3 from Donga region, so we use the same labeling code. Number 1 for Donga region, or 3 represents the household, and the last digit is for the sampling round, 6th round. So LT stands for light trap and female, CX stands for Culex, and the date of today, which is 5th of April 2022. So this is the sample label, which would then stick it to the Pendorf tube, and it can be kept later for storage.
So now we are ready, we are done with our data collection. We have all the data with us, and we have processed the data already, and we have identified the mosquitoes into species, adult mosquitoes into species using morphological identification key, as you just saw, and now all the data is ready for further analysis to be able to answer our original research question.